So let me do an introduction on functions. Okay, suppose you have f of x is equal to root of x square minus 4 is the question. Okay, in that case, that is y is equal to root of x square minus 4. You know, this can become 0. So x square can be 4. And x square can be greater than 4 because root cannot take negative values. X square has to be greater than 4. So x has to be greater than plus 2 and x has to be lesser than minus 2. So then you know that x can also be plus or minus 2 inclusive, because this numerator 0 is allowed. So then write a minus 2 and a plus 2 in the number line. X has to be lesser than minus 2 and equal to minus 2, and x can be greater than plus 2. So till infinity and a minus infinity. So answer is minus infinity to minus 2 union plus 2 till infinity, where plus 2 is also inclusive till infinity. This is the domain, or x is an element of. Suppose they ask you for range. Take this question, y is equal to x square minus 4, and you know that you can root of x square both sides. So then you find what is x from this. Y square plus 4 is equal to x square. X is equal to root of y square plus 4. So then therefore again this is y square. Anyway it's going to take only positive values. Even if y is negative, it's going to become positive. The root will never be negative in this. So you know that y can take any value here. Y can take any value. But you can't write that because by definition a square root is always positive. You might ask me, square root of 4 is plus or minus 2, but that doesn't apply in functions. In functions, they always say any square root functions takes only the range is always positive only. So then you know it's positive real numbers. Y is always a real positive numbers, R plus. Okay, and also it is going to start with, even if this is as any square number, the lowest value the square number can take is 0, and a 0 plus 4 is root of 4, which is equal to 2. So it starts only from 2. It doesn't start, even you don't get answers which are less than 2. It starts from 2 till infinity. I hope you understood. I'll explain once again. Y is equal to root of x square minus 4, square both sides. You get it like this, x square minus 4, take it, that's it. Y square plus 4 is equal to x square. X is equal to root of y square plus 4 shows that y can take any real number, correct? Y can take any real number, but however square root functions, whenever they give you square root as a function, the f of x will always be positive numbers only. It will never be negative. By definition it's like that. So even if y is going to be 0, y square is going to be 0, the lowest square number is 0 plus 4. The answer will start from 2 onwards till infinity. So y is going to be a close bracket 2 till infinity. Okay, so that's about this. What happens in the same question comes in the denominator. The question is f of x is equal to 1 by root of x square minus 4. Denominator can never be equal to 0. So x square cannot be equal to 5, x cannot be equal to plus or minus 2. And x denominator, the root should not be negative, so x square should always be greater than 4. No equal to 4 here, greater than 4. X has to be greater than plus 2 and x has to be lesser than minus 2. Put it on the number line, minus 2 and a plus 2. Minus infinity here and a plus infinity here. You know that the x can be taking values which are greater than plus 2. Don't fill it because it cannot take plus 2 and minus 2. Lesser than minus 2 till minus infinity. So minus infinity to minus 2, both of them open bracket, union plus 2 to infinity, again open bracket only. The difference between this sum, here it will be closed because it was in the numerator, but here it's in the denominator, so it will be open. Other than that, the answers will all be the same. But in the case of range, I've told you range means y. In this, it should only be positive answer again. So just take it, y is equal to root of x square minus 4, square both sides is 1 by x square minus 4, cross multiply, you get x square y square minus 4 y square is equal to 1. Get what is x square from this, which is 1 plus 4y square by y square. X therefore is root of 1 plus y square by y, which shows that y cannot be 0. So then y cannot be 0. Also y has to be only positive numbers. Y has to be only positive numbers which cannot be 0. So open bracket 0 till infinity. Or you can say real positive numbers. Okay, so then that's about y, and I hope you understood. Let's go to next question, next format. The third format is 1 by, okay, let's write it in the numerator first. F of x is equal to root of 4 minus x square instead of x square minus 4. And in this, the numerator only, it can be 0 and the negative should not come. So then therefore x square should be lesser than or equal to 4. X has to be lesser than or equal to plus or minus plus 2. And x has to be greater than or equal to minus 2. Put it on the number line, a minus 2 and a plus 2, an infinity and a minus infinity. X has to be greater than or equal to minus 2. X has to be lesser than or equal to plus 2. What is intersecting part is this part, which satisfies both the conditions. So therefore x is an element of minus 2 inclusive to plus 2 inclusive, and that's the value x can take. This is my domain. And what about range? Y is equal to root of 4 minus x square. You know that x square always takes a value which is less than 4. Okay, so then the maximum value, this can be 0. X square can be 0 and can be root of 4 minus 0, which is root of 4, which is 2. That's the maximum value that y can take, and the minimum value can be, if this is 4, 4 minus 4 is 0. So y can range between 0 inclusive to plus 2. Both of them close bracket. So what happens when the same sum comes in the denominator? 1 by root of 4 minus x square is f of x. In this, denominator cannot become 0. So x square cannot be equal to 4. So x cannot be equal to plus or minus 2. Also 4 has to be greater than x square, no equal to. Or x square has to be lesser than 4, x has to be lesser than plus 2, or x has to be greater than minus 2. When you put a negative symbol, the greater than symbol has to be. So put it on the number line, a minus 2 and a plus 2, a plus infinity and a minus infinity. X has to be greater than minus 2. Don't fill it, okay? X has to be lesser than minus 2, lesser than plus 2. So the intersection is open bracket minus 2 and open bracket plus 2, and x is an element of this. So that's how you define, and the variation you can clearly see, that is close bracket here because it was a numerator, it's open bracket here. They ask you why. Obviously you have already done all this work to find y. Here y is an element of 0 to 2, but in this sum you see y will never be 0 because 1 by any number can never be 0. Okay, and also let's say y is equal to 1 by root of 4 minus x square, squaring both sides, 1 by 4 minus x square. So 4y square minus y square x square is equal to 1. So then taking this to the other side, y square x square is equal to 4y square minus 1. X square is equal to 4y square minus 1 by y square. X is equal to root of 4y square minus 1 by y. This sum is going to get complicated. Y cannot be 0 and the root cannot be negative. So 4y square has to be greater than or equal to 1. Because it's a numerator, I can put equal to symbol. Y square is greater than or equal to 1 by 4. Y is greater than or equal to plus 1 by 2, and y is lesser than or equal to minus 1 by 2. You also know y cannot be 0. Put it on the number line, a minus 1 by 2 and a plus 1 by 2. Okay, y has to be greater than or equal to plus 1 by 2. Fill till infinity. Y has to be lesser than or equal to minus 1 by 2 till minus infinity. And y cannot be also 0, but anyway we have not included all these values too. So no problem. Minus infinity till minus 1 by 2. With a close bracket and open bracket, union plus 1 by 2 till infinity with open bracket and a close bracket. However, this is a square root function. Square root function, the y value can never be negative. So negate this y value that I have written and stick to plus half till infinity. Y is an element of, and this should be your answer. Hope you understood this. So then, so I am teaching you different patterns. What happens this is in the numerator? What happens when this is in the denominator? What happens when this pattern is switched? It's 4 minus x square. What happens when it's 1 by root of 4 minus x square? So like this you should understand the different patterns that comes your way. and solve it. Okay, so then when it's 1 by, the y value can never be 0. You just cross multiply and find from here y cannot be 0, root kulla negative it should not come, and so then therefore you can infer from it. So then let's go to next question. Supposing this question is f of x is equal to minus mod x. There is no numerator, denominator, no, that's just numerator, that's all. X can therefore take any real number. What about y value? This is mod values. Mod value can be only 0 till infinity. And a minus comes here, so it's 1 means minus 1, 2 means minus 2. Outside the mod there's negative sign. So therefore it's minus infinity till 0. So then x is an element of real number, but y is an element of minus infinity open bracket till 0 inclusive. It's all, so you understood how to write this. Let's go to next sum. So next sum is f of x is equal to, let's say x square plus 2, simple functions like this. You know, any square number, the lowest value is 0 and the highest value is infinity. So add a plus 2 to it, this will also be plus 2 and this will also be infinity. So then x can be an element of all real number because there are no conditions applied here, it's just numerator. And no square root also, and y is going to be an element of inclusive of 2 till infinity open bracket. So let's go to next pattern, and f of x is equal to, let's say, let's take let's consider a sine 2x plus 1, some question like this. You know, this is sine 2x, any sine value always lies between minus 1 and plus 1. In trigonometry you should know, in sine 90 is 1, sine 270 is minus 1, that's maxima and minima you can have. Now take a plus 1 and add plus 1 on every side. Take the first equation, add plus 1. So thus you got the question itself here, and this becomes 0 and this becomes a plus 2. So then therefore a sine 2x plus 1, and the y value always ranges between 0 and 0 inclusive till plus 2 inclusive. So inclusive of 0 to inclusive of plus 2 is what is my y. What about x? X is an element of any real number. How is it? Sine 2 into infinity can come? Or minus infinity can come? Yes, because first revolution, the x is nothing but this 360 degree, 720, 1080, and it can go up to infinity. These radian measures can go up to infinity. So x is an element of all real number, y is an element of 0 to 2. So let's go to next question. Next question is like, so sometimes they'll give you mod of sine 2x minus 1 or minus 4. Let's take it like this. And this is f of x. You know that sine x can be an element of all real number because it's radian measure. And they ask you for, you have to do this, sine 2x lies between, for y it's minus 1 plus 1. And put a minus 4 everywhere. Minus 4, minus 4, minus 4. So this will become minus 5, and this will become a sine 2x minus 4, and this will become a minus 3. And there is also a mod. Okay, so then this therefore will lie between 5 and 3. 1 second, hold on. So whenever you do a mod, you should always change the symbol also. So then therefore if this gets changed like this, okay, so then therefore it lies between 3 and 5. Remember that when you're applying a mod, okay, you have to change the symbol here. So that's a moral of story for that sum. So let's go to next. Okay, some question like this, f of x is equal to x square minus 25 by x plus 5. You know the denominator cannot be 0, so x cannot be minus 5. And then that's your domain, so x is an element of all real number other than minus 5. That's your answer. This is the way you should write. And for y, you know what you should do to find y, you should write x plus 5 into x minus 5 by x plus 5. This and this get cancelled. You know x cannot be minus 5, no? Therefore y cannot be minus 10. So y can take all real number other than minus 10. So such a beautiful question. So next is, so the next question is the 9th question, where they ask you f of x is equal to 3 by 2 minus x square. Find the domain and range. You know, x square cannot be equal to 2 because denominator will become 0. So x cannot be equal to plus or minus root 2. So a domain, x is an element of all real number other than plus or minus root 2. So then now let's find the range. For finding the range, just cross multiply always, okay. 2y minus yx square is equal to 3. So take the x square to the other side. Yx square is equal to 2y minus 3. Bring the y down. So x is equal to root of 2y minus 3 by root y. Okay, so look at this. You get your x and you know y cannot be 0 from the denominator. You know y cannot be 0. You also know y cannot be negative, because inside the root you should not get negative number. So y has to be any number greater than 0. Also go to the numerator now. There is root of 2y minus 3. So 2y has to be greater than or equal to 3. So y has to be always greater than or equal to 3 by 2. Y has to be greater than or equal to 1.5. Y has to be greater than not only 0, it has to be greater than 1.5. So the intersection is y has to be compulsorily greater than 1.5. Okay, so this is one condition that strikes us. So then definitely y has to be greater than 1.5. It can range from 1.5 till infinity open bracket. But however, we can study in other way also, where if you see the numerator also can be negative and the denominator also is negative, the negative and negative will get cancelled. So it's possible for both of them to be negative. It is possible for both of them to be negative. In that case, the y, if y is any number less than 0, thinking about the denominator and taking the numerator, 2y can also be lesser than 3. Y can also be lesser than 3 by 2 or equal to, because numerator it can always stay less than or equal to. Y has to be lesser than 3 by 2, which is y has to be lesser than 1.5. So the answers can also be from minus infinity till 1.5. Correct? 1.5 inclusive, union. So this is the answer. So when I say it has to be lesser than 0. But when I come in this direction, you see 1.5 comes after 0. Correct? So I cannot include 0. I cannot include 0. So then I should put a 0 and then put a open bracket. And y has to be necessarily greater than 1.5 from here. And you know, from this derivation, y has to be lesser than or equal to 1.5. But you know, y cannot be 0. So what is intersection? Y cannot be 0. And y can be less than 0. So y can be less than 0. Y can be lesser than or equal to 1.5. So intersection part is this. So y has to be less than 0. So this is the answer. Very, very important question. I hope you understood. So let's go to 10th question. 10th question is this, which is f of x is equal to 1 minus mod of x minus 2. You see this mod value can be from 0 till infinity. And a 1 minus and a 1 minus from here shows that the least value it can take is, no, maximum value it can take is 1. The least value it can take is minus infinity. You know, from this x can be an element of R. There's no root, there's no denominator. But y can be from minus infinity till 1, close bracket. And this is open bracket. Okay, so that's this 11th question. I'll do 11th question. The simple questions such as f of x is equal to mod of x minus 3. Okay, x can be an element of all real number. Mod functions take a value from 0 to infinity. So y is an element of all real positive numbers, or you can say y is an element of 0 inclusive till infinity open bracket. Let's go to next question. So then this question, f of x is equal to 1 plus 3 cos 2x. You know, cos 2x value lies between minus 1 and a plus 1. You multiply every side with a 3. And then add every side with a plus 1. So this question is going to lie between minus 2 and a plus 4. There's no mod. If you're inserting a mod, then I have to change the symbol. So it's going to lie between minus 2 till plus 4 inclusive, and that will be my answer. Okay, that will be y is an element of, and x of course is an element of all real number. You know, radian measures can go up to infinity in this 13th question. Let's go to next sum. So let's take this question, which is f of x is equal to mod of x minus 2 plus mod of 2 plus x, where x is lying between minus 3 and plus 3. Okay, so mod of we have to redefine this function. The question is redefine mod function. Redefine mod function. So to redefine the function, okay, they've already given it to be minus 3 to plus 3. Forget about it. What is the cutting point here? You know, when you draw this graph, the cutting point here, the sharp edge will be at 2. When you do this graph, the sharp edge will be at minus 2. Okay, so then therefore you can do the graph with minus 2 and plus 2, minus 2, plus 2, and there's also a minus 3 given in the question and a plus 3 given in the question. They're asking you to redefine this function in this interval. Give one example and see. Let's give one example between minus 2 and minus 3. Can I write it as minus 2.5, which is 5 by 2? So write here minus 5 by 2. Minus 5 by 2 minus 2 is definitely negative. Some negative answer. Ignore the mod and put x value. 2 minus 5 by 2 is again negative. Both of them are negative and negative. So if the formula will become minus x plus 2 minus 2 minus x, which is minus 2x. The function has been redefined now. You got, this is the example you substituted, and you got answer as my f of x redefined as minus 2x. Between plus 2 and minus 2, let's take an example which is 0. Substitute in 0 here. 0 minus 2 is negative. 0 plus 2 is positive. So this function is negative minus x plus 2. Positive plus 2 plus x. X and x get cancelled. F of x itself is becoming 4. Thus you redefine the function. Next, take one example here which is plus 5 by 2. Substitute it in 5 by 2 minus 2 and a 5 by 2 plus 2. Plus 5 by 2, 2 plus 5 by 2. No, this is going to become negative. 5 by 2 minus 2, no, positive only. This is also positive. So both of them are positive. So x minus 2 plus 2 plus x. So it's 2x again. So thus you are able to redefine the function. When you write it, you should write when x is lying between minus 3 and minus 2, the new f of x value is minus 2x. When x is lying between minus 2 and plus 2, the new f of x value is 4, and plus 2x when x is lying between 2 and 3. Like this you can redefine the function. Okay, so you get but somewhere you have to include and exclude. So in this if I'm going to include the minus 3 here, I'll exclude the plus 2. In the second case, I'll include the minus 2, I'll exclude the plus 2. In the next case, I'll include the minus 2, and I'll also include the minus 3. So in these cases alone, if you include, then this has to exclude in this interval. In this interval, you have to include, and this you can exclude. But in this interval, you can include both. This is how you redefine the function. I hope you understood how to redefine the function. So let's go to next question. The 14th question is this. They've given f of x is equal to x minus 1 by x plus 1. They're asking you to write what is f of minus 1 by x. So in the place of x, you have to substitute minus 1 by x. So minus 1 by x minus 1, minus 1 by x plus 1 will be minus 1 minus x by x by minus 1 plus x by x. X and x anyway get cancelled. You can write as minus of 1 plus x. No, just leave it like this. This is the value, that's all. You get this answer, leave it like this. And whenever you do this, you should write x cannot be equal to plus 1 because denominator cannot be 0. You should always write this, okay? Otherwise they won't give you marks. Okay, so then that's my answer. So let's go to next question. Next question is select this when they can ask you anything. Okay, this is x is getting replaced by minus 1 by x. So I'm doing this sum, and anything they can ask you. So let's take next sum. F of x is equal to root x. G of x is equal to x. They're asking f plus g of x, which means you have to add f of x plus g of x, which is simply root x plus x. Simple sums like this. 16th question, f minus g of x for the same question is root x minus x. F into g of x, which is f of x into g of x. To multiply both, which is root x into x, which is nothing but x to the power 1 by 2 into x, which is x to the power 3 by 2. You know, it's like powers will have to be added in exponents. Next is f by g of x, which is f of x by g of x, where g of x cannot be equal to 0. Very important. What is f of x? Root x. What is g of x? Is x. So then you know this is the answer. You can also cancel it, or you can write, keep it as it is, but where x cannot be equal to 0. It's a very, very important thing. And you know, x can also not be negative, because whenever there is just root x, 1 by root x, you know, x cannot be negative. X has to be greater than 0. So just, you know how you write it, and so write it like that. So let's go to 19th question. I think I'm done. There's one more question, which is f of x is equal to x plus 1 by x will be in Arora or R.D. Sharma, where they'll ask you to write f of 1 by x. Okay, so in this case, f of 1 by x will be 1 by x plus 1 by x, which will be x. Okay, so some sums like this you should be able to manage and do. So let's go to next question. If there are any hard sums other than this that I would like to do once again. Is a given function, if you're given relation of function, so they have given this question, a 4 comma 6, a 3 comma 9, a minus 11 comma 6, a 3 comma 11. Okay, they've given h to be the function. They're given a relation, which means they're asking if it will be a function. The first element of the ordered pair is occurring only once. Correct? 4 is getting mapped to 6. A 3 is getting mapped to 9. A minus 11 is getting mapped to minus 11 is getting mapped to 6. A 3 is getting mapped to 11. A 3 is occurring twice. That's all gone. If the first element of the ordered pair is occurring twice, it is not a function. It is not a function. It's only a relation. 3 is occurring twice. You know, in a function, how do you draw a graph? You are the one who is assigning x value to find y value. If you give 3, supposing in a function is x plus 4, 3 means it will become 7. Will you again give 3? It will again get you 7 only. It can't get you a different answer. If it gets you 3 is getting mapped to 2 different values, it cannot be a function. The first element of the ordered pair should occur only once for it to be a function. I hope you are clear. So let's go to 21st question. They've given this f is equal to x comma x, where x is a real number. X is a real number. Okay, what are they saying? Is this a function? X comma x, which means this in the place of x and y you have x and x, which means y is equal to x. It's a identity function. When x is 1, y is 1, x is 2, y is 2, x is 0, y is 0. It's 1 comma 1, a 2 comma 2, a 0 comma 0. It's like f of x is equal to x. It is definitely it's called an identity function. It's called identity function. Okay, so then now next question is the 21st question. Is g is equal to n comma 1 by n, where n is a positive integer. N is a positive integer. So then they've given this to be x and this to be y, which means this is x and this is y. X is n and y is 1 by n. N is a positive integer. What are the positive integers? If it's 1, it will be 1. If it's 2, it will be 1 by 2. If it's 3, it's 1 by 3, and so on. So then what are they asking? Is this a function or this is definitely a relation? Is this a function? According to me, if I write one value of 1, I am getting only unique values of y. Everything is getting mapped to unique values. So then for the third question, I would say definitely g is a function. G is a function because the first element of the ordered pair is occurring only once. So that makes sense. Okay. So then 22nd question is they've given s to be n and n square, where n is a positive integer again. okay, a positive integer. N is a positive integer, you write n is 1, it will be 1, n is 2, it will be 4, n is 3, it will be 9. So definitely the first element is occurring only once in the mapping, and so it is definitely a function. It is a quadratic function, to be very honest, n square. For every value of x it's getting squared, it's a quadratic function. But if the question was not positive integer, the same question was given generally an integer, n is an integer, even then it will be a quadratic function. Even minus 3 is getting mapped to 9, 3 is also getting mapped to 9, but still the first element is occurring only once now. The second element is occurring twice, does not matter. So this is again a quadratic function only. It's again a quadratic function. This relation becomes a function. So let's go to next is this question, which is sum number 23. They've given x comma 3, where x is a real number. Okay, a real number. Therefore, they've said x is any real number. Every time you write x as 1, it's mapped to 3. X as 2 is mapped to 3. X as 3, it's mapped to 3. X as 4, it's mapped to 3. It's a constant function. Y value is always 3. Y is equal to 3 is known as constant function, and it can be definitely a function. Okay, this relation can also be a function. So next is so then they might give you questions like this, 24th question, where they are giving you f of x is equal to x square plus 7 and a g of x is equal to 3x plus 5. And they might ask you what is f of 3. F of 3, in the place of x substitute 3, it's 9 plus 7, write that value. And they might ask you g of minus 5, substitute in the place of x substitute minus 5, it's minus 15 plus 5. Then they might ask you f of 3 plus g of minus 5. Add this answer, so 15, 16, and add this answer, which is minus 10, and write the total answer. So there can be questions like this which will be asked, and you should be able to answer it. Okay, so let's go to next kind of questions that can come. So they'll ask you some questions like this, which is a 2a plus b comma a minus b is equal to 8 comma 3. It's called equal set. Sets. 2a plus b is equal to 8, a minus b is equal to 3. So solve it like linear equation, get the value of a and b. That's all. Very, very easy. Okay. So you will eventually get a to be 11 by 3, and b to be 2 by 3 if you solve this linear equation. Such questions might come, which is very, very simple question. And then it's all sets. I'm sure you know what is how to write sets. I don't have to teach. You just want me to do it only from relations, functions. So I'm only doing functions. Okay. So it's thorough this, and also various graph of all different types of graphs, which is there in the previous video that I've sent. Okay.